This section examines tanks and lines. Where the tank is mounted depends on where the engine is and on space and styling. Safety demands that it is positioned well away from heated components and outside the passenger compartment. Most tanks are made of tinned sheet steel that has been pressed into shape. Some passenger car tanks are made of non-metallic materials. Aluminium or steel is used on commercial vehicles. The tank is usually in two parts, joined by a continuous weld around the flanges where the parts fit together. Baffles make the tank more rigid. They also stop surging of fuel and ensure fuel is available at the pickup tube. Fuel expands and contracts as temperature rises and falls, so fuel tanks are vented to let them breathe. Modern emission controls prevent tanks being vented directly to the atmosphere. They must use evaporative control systems. Vapour from the fuel tank is trapped in a charcoal canister and stored there until it is burned in the engine. A vapour or vent line with a check valve connects the space above the liquid fuel with the canister. This valve opens when pressure starts to rise and lets vapour through, but not liquid. Liquid fuel closes the check valve and blocks the line, stopping liquid fuel reaching the charcoal. Some systems have a small container called a liquid vapour separator above the fuel tank. It also prevents liquid fuel reaching the charcoal. This petrol tank has a small separator tank and a number of vents. They're from different parts of the tank, so that for as many vehicle positions as possible, at least one is always above the level of petrol in the tank. Fuel lines are usually made of metal tubing or synthetic materials. A fuel supply line carries fuel from the tank to the engine. A return line may also be provided to allow excess fuel to return to the tank. This helps prevent the formation of vapour that can occur in the fuel supply during hot conditions. The fuel filler is where fuel enters the system. The filler neck is a pipe that extends above the fuel tank. On unleaded petrol vehicles with catalytic converters, the filler neck is designed to prevent leaded fuel being added. Its diameter is smaller than those on leaded vehicles, and a trapdoor inside the filler can only be opened by the nozzle of the unleaded petrol spout. The filler cap seals the filler neck to keep out water and foreign objects. Water can corrode internal passages of fuel pumps and carburetors. The cap on the petrol tank also stops petrol vapour escaping and polluting the atmosphere. This is important for petrol, which is very volatile and vaporizes easily, especially in warmer climates. Some petrol caps have a low pressure valve built in. It keeps a balance between the pressure in the tank and the outside atmospheric pressure. As petrol in the tank is used, the airspace above the fuel increases. This causes a fall in pressure compared to outside atmospheric pressure. The valve then opens and lets more air into the tank. A fall in temperature can cause a fall in the pressure in the tank. The valve opens to admit more air till inside and outside pressures equalize again. The fuel gauge shows how much fuel is still in the tank. It has a gauge unit on the dash and a sender unit in the tank. This unit indicates the level of fuel in the tank and transmits this information to the gauge in the dash panel. The charcoal canister is a canister of activated charcoal, and it's a temporary storage device for vapour from the tank. When the engine is stopped, vapour from the tank passes through the vent pipe to the canister and is absorbed into the charcoal. When the engine is running, the lower pressure in the inlet manifold draws in the petrol vapour from the charcoal into the manifold. The process is controlled so it doesn't upset the air-fuel mixture. This section examines filters for carburetted engines. Fuel must be kept clean, or the jets in the carburetor could be blocked or corrosion can occur. So fuel systems always contain filters. In this carbureted system, a fine filter of nylon or gauze is fitted to the pickup pipe in this petrol tank. A large surface area is provided to allow adequate flow rate and better filtering. An inline filter, usually made of clear plastic, is either between the tank and the pump or between the pump and carburetor. This filter traps dirt and water. The amount of water can usually be seen through the plastic.